All right, advanced math A, we got lesson 10.1.4, standard deviation. All right, so a biologist is trying to determine which sugar is more successful in growing a particular eukaryotic cell, maybe. The data from the two sugars is below. All right, so we've got our first sugar, W. We're going to make a histogram and a box plot, and they tell us where the intervals are, so that makes it really nice. So let's go ahead and set this up. So this is going to be sugar W. So this will be 10, 20, 30, 40, 50, 60, 70, 80. So they said to go from 10 to 80, and each bin is going to be a width of 10. All right, then we got 2, 4. So this is the frequency on this side. All right, so we're looking at sugar W. All right, so in that first bin, 0 to 10, nothing goes in there. And then there's one number in the next bin. So there's that one. Nothing goes into 10 to 30. 30 to 40, we got 1, 2, 3, 4, 5, 6, 7, 8, 8. So that one goes up to 8. 40 to 50, 1, 2, 3, 4, 5, 6, 7, 8, 9. Goes up to 9. 50 to 60, nothing. 60 to 70, nothing. Remember, 70 starts the next bin, so our last bin is 1 unit high. So we're supposed to also do our box plot. It doesn't say modified, so it's a regular box plot that's going to have like outliers in it and everything. So this would be the minimum. This would be the maximum. There's 19 numbers here. So this is the very middle. And then the middle of this data, there are 9 numbers here. So the middle of this data is right here. Then up here, not counting the 40, there's 9 numbers. So the middle of that would be right here. So there's my 5-number summary. This is my minimum, Q1, median, Q3, maximum. So I would put that up here. Here's the minimum. 34 would be, right about here-ish. 40 right here. 45 is right here. And finally, 70 goes right here. So this is my middle 50% of my data. And here's my whiskers. So you can see that our middle 50% of our data is really tight in there. It's got very little spread. Then we got these big whiskers on each side. Let's do sugar P. So for sugar P, we'll set it up. And we'll do the same bin sizes for this one as well. So we'll do 10, 20, 30, 40, 50, 60, 70, 80. And 2, 4, 6, 8. All right, so for the first bin, 0 to 10, nothing. From 10 to 20, I've got 1, 2, 3. It doesn't count 20, so just 3 in that bin. From 20 to 30, I've got 1, 2, 3. It doesn't count 30. 30 to 40, I've got 1, 2, 3 again. 40 to 50, I've got 1, 2, 3 again. Starting to see a pattern here. 1, 2, 3 for 50 to 60. 2 and 60, 2 and 70. So I got 2, 60 to 70, and 2 there. Okay, to find our 5-number summary for our box plot, minimum, maximum. This is our median, because there's 19 numbers. So that's the 10th number. There's 9 on this side, 9 on this side. And then the middle of this data right here would be 25. So we're not counting the 40, it's just these 9 numbers. This is the number in the middle. Of these 9 numbers up here, not including 40, the middle is 55. So there's our 5-number summary for that. And we'll go ahead and put it up here. So this is sugar P. Get over here, you. So we've got our first number at 10, which I believe is right here. Next number is at 25, right here. Next number is at 40. 55 is next. And then 70. All right, so there we've got part A done. Next one says calculate the mean for both. It said here that the sum of both data sets is 760. So we would take the sum of the numbers and divide by the number of the numbers. So we would do 760, and there's 19 numbers. So our mean for both of them is 40, and that happens to also be the median for those. So they have the same mean and the same median. So does that mean that the two sets of data are the same? Obviously not. We can tell by looking at the histogram that they're not the same. Describe the shape and center of each graph. Okay, so the shape of sugar W is symmetric. Because if you drew a line down the middle, it's about the same on either side. Now, when we have symmetric data, we want to use the mean as our best measure of center. It doesn't really matter on this one because the mean and the median are the same, but generally we would use the mean when it's symmetric. For sugar P, it kind of is symmetric, but more specifically, it's uniform. These are almost all the same. So when they're almost all the same, we call uniform. And uniform, we also use the mean. The only time we use the median as our best measure of center is when our graphs are either skewed, where that's where all the data is on one side or the other, or a lot of it is, or when we have outliers on just one side of our data. Here we had outliers, but they kind of balanced each other out because we had some on one side and some on the other one. So that's when you would use the median, is when you have skewed or outliers sitting on one side of your data. Which sugar appears better? Well, they have the same center, so you can't use the center to decide which one's better. So then you'd move on to what we call spread. And here, this box here, the IQR, that's the middle 50% of our data. It's not a very big box. That means the center is not spread out that far. Whereas this box, the IQR, the difference between Q3 and Q1, we've got a bigger spread of the data. So we would say the one with less spread is better data. So sugar W is better because its spread is lower. And when it has a lower spread, it just means that it's more consistent. So that's what you're looking for. If the centers are the same, then you move on and you start looking at the spread of the data. Now, there's more than one way to measure spread. Range is one way that you can measure spread. That's just range is the maximum minus the minimum. And both of these have the same exact range. They have a maximum of 70, a minimum of 10, so the range is 60. Now, why might we not use the range in this one? Well, especially on sugar W, we've got probably outliers here. So usually the highest and lowest numbers aren't very descriptive of what's really going on for most of the numbers in our data. So generally, we don't use the range, okay, because those don't usually represent the data very well. So the highest and lowest numbers usually don't represent the data well. Usually we'll want to look at the middle of our data. That's usually where our best data is, somewhere sitting in the middle. IQR, interquartile range. So this box is the interquartile range. So from whisker to whisker, that's our range. And then this is the IQR, the interquartile range. And the interquartile range is just the spread of the middle 50% of our data. So for sugar W, the IQR, Q3 was 45, Q1 was 34, so that's a difference of 11. For sugar P, the IQR was, Q3 was 55, Q1 was 25, so we get an IQR of 30. And we can see what the graph told us, that the spread of P, it was more spread apart, and the spread of W was less spread apart. Now there's a problem. IQR is based off of the medians. So when the median is your best measure of center, your best measure of spread is going to be IQR. But our problem's up here, the best measure of center was mean. So IQR doesn't go with mean, it goes with median. So what we need to do is look at standard deviation. Standard deviation is based off of mean. So that is the best measure for spread when the best measure for center is the mean. Here's a formula. So this is the symbol for standard deviation right there, like a little circle with a line on top of it. And here's the formula. It's a very simple formula. It looks kind of difficult right there, but here's what it says. It says first that you should take x1 minus x bar. And x1 is each number in your data set. So that's what x1 represents. X bar is the mean. So step one is you subtract the mean from each number. Step two, the next thing it says here is we're squaring that. So all of these differences that we've just made here, we're going to square them. Next step, this symbol means sum. So all those numbers that we just got done squaring, we're going to take the sum of the squares. And then that's the numerator. The denominator says n. That means the number of numbers. So after we've taken the sum, we're going to divide it by the number of numbers. In this case, there were 19 numbers in our data set, so we divide by 19. And then the last step is we take the square root. All right, so let's flip it over. We're going to actually find the standard deviation for sugar W and sugar P. It looks like a lot of work, but it's actually not that hard. So we know that our standard deviation, our mean is 40. So step one, subtract the mean from each number in our data set. So I'm going to use 40 all the way down here. All right, so I would do 10 minus 40, negative 30. What do I do next? I square that. So negative 30 times negative 30 is 900. And we're going to do that for all 19 of these numbers, and then we're going to do the same thing for our other data set. So here 10 minus 40 is negative 30. And then over here we'd get 900. All right, I'm going to pause and fill in the rest of this data. All right, so I have finished doing all my calculations. So I have done all my numbers. These are all negative numbers, but when you square a negative number, you always get a positive number. So we got all positive numbers. Now that's the reason why we're squaring over here. If I didn't square and I just added up all these numbers, it would always come up to 0 if I did that. So if I just took all those numbers and then added them up, it'd always come out to 0 because I'd have some negative numbers and then the positive numbers would cancel those out. So that's why we square them, so that we can make them into all positive numbers. So I've done that for both rows there. So you can see I've got all those numbers there. Okay, so after we've squared the differences, now we take the sum of all of those numbers. So the sum of this set, if you do it in your calculator, is 2240. The sum of this set over here is 6766. Okay, now according to our formula, which is the square root of the sum of x1 minus x bar squared over n. So far, we've done the numerator. We found the sum of all these squares. Now we're going to divide it by the number of numbers. So I'm going to take the sum and divide by the number of numbers. So I've got 2240, and there were 19 numbers here. Now on my calculator, it comes out to about 117.9-ish or so. And now I take the square root. It's lunchtime. I got to hurry up and finish this. All right, so now I take the square root, and we get approximately 10.9. On the other set of data, I do the same thing. I take the sum divided by the number of numbers, so that's 6766 divided by 19. That comes out to approximately 356.1 square root, and we get 18.9. So this is just another measure of spread, and this is, we can tell, this one is less spread out because its standard deviation is smaller. So that means this data over here is more consistent than this data here because it's got a larger spread. So this is more consistent data. All right, that's all I got for you. Math hard, and I will see you guys later.